Hello friends, today we'll be doing a coolant change on the 6th generation Mitsubishi Mirage. This tutorial covers vehicles made from 2012 to today. A parts list has been included in the description below. Let's start off by briefly talking about cooling system maintenance. Here you can see there are two caps. To the left is the radiator cap and to the right is the coolant overflow reservoir. And if you look at the coolant overflow reservoir, you can see there's the letter F and a line. That indicates that the coolant is at the full level, and the L would indicate the low level, which means you have to add coolant. Coolant level should be between those two lines. I'd like to take a moment to talk about safety. I guess the biggest safety concern when working with coolant, the most entertaining one at least, is the fact that coolant is sweet tasting. Sometimes people use it to assassinate people, although that's not really relevant here. The biggest safety concern to us today is that this vehicle, just like many other vehicles on the road today, uses a pressurized cooling system. The concern with unintentionally releasing all the pressure and hot steam of coolant in your face is so great that some manufacturers, such as Toyota, even recommend against ever opening the radiator cap in the owner's manual. Now let's talk about how to open the radiator cap. So you should start off by always wearing safety glasses. Always wear your eye protection. Now we will touch the radiator cap and determine if it's warm or not. If it's warm, we will not open it at all. And you can see here I am going to use a paper towel to open it, just in case there's any pressure or hot steam so it doesn't come out and burn my hand. Alternatively, you could use like a real towel or like an old t-shirt. If you're wondering how long to wait before opening the radiator cap, I'd recommend waiting multiple hours since you've last run the vehicle. To illustrate how long coolant stays hot to you guys, I'm able to go to the gym, watch the TV at the gym for an hour, get back in the car, turn it on, and the cold coolant light isn't even on. The coolant is still warm. The radiator cap is not threaded. It takes a little bit more than a 90-degree turn to remove it. Now that we've got the radiator cap off, we can look in and see that the coolant system is full, which is a good sign. Now we will talk about when to change the coolant. Of course, you can follow the owner's manual, do your first change at 120,000 miles or 8 years, and every change thereafter at 90,000 additional miles or 6 years. But I will also be showing you two different ways of determining the health of your coolant. First test I will be demonstrating to you is a pH test. As you can see here, I'm opening my pH test strip indicators. I bought 400 test strips for $10 on Amazon with free one-day shipping. These test strips come with and are shipped in an airtight Ziploc bag because they don't want the test strips reacting with the humidity in the air during storage and transport. So as you can see within the little booklet, there is a scale for what pH value correlates to what color of the test strip. All we're going to do is dip one of these test strips into our coolants, wait a few seconds, and compare our results to the card. If you're wondering why I'm dipping this into the radiator instead of into the overflow reservoir, it's because the coolant in the overflow reservoir is much newer, as I've had to add coolant recently. So as you can see here, my pH value appears to be between 9 and 10-ish. An ideal value would be between 7.5 and 9. The second coolant health evaluation test I'll be showing you today is a freeze and boiling point test. I bought this tester off of Amazon for $16 with free one-day shipping. This works similar to a turkey baster. You're just going to squeeze the ball at the top, and let go, and let it suck up coolants. Now that our tester is full of coolants, we can take it out and look at it. The coolant from the factory comes with a freeze point rating of minus 34 degrees Fahrenheit. So you can see here my rating is right around minus 20 degrees Fahrenheit, so this coolant has deteriorated quite a bit. On the flip side of the tester, you can see a boiling point, but I'm not too concerned about that. The freeze point that is desired for you depends on kind of where you live. If coolant does freeze in your engine, whether or not the engine is run, you will break the engine block. Now that we're done performing our test, we can go ahead and put the coolant right back into the radiator. Before we go any further, I'd like to take a minute to appreciate how ingenious this radiator cap design is. It's a metallic cap, which allows you to feel that it's warm when the coolant is warm. It has these two kind of wings or tabs that engage with the top of the radiator. Looking at where the cap goes, you can see kind of two notches or slots where the wings would go. So as you can see, here's one kind of cutout area for one of those two tabs, and here's the other directly opposite from it. That's why the radiator cap can only go on and come off in one particular orientation. And you can see those tabs again on the radiator cap. You can see kind of how they line up for you to put it back on. There's two ways for you to be able to put this on. One is with the logo facing away from you, and one is with the logo facing towards you. Yes, so we're just going to line up those tabs with those cutouts. We're going to put our radiator cap on. We're going to push down because it's spring loaded. It's a little hard to do with one hand, and we are going to twist. One other rather interesting aspect of the cooling system is how the overflow reservoir is plumbed into the rest of the cooling system. As you can see, there is only this one hose that goes from the radiator cap area to the overflow reservoir. And if you think about it, with gravity, coolant in the overflow reservoir would never make it into the radiator. So the way that coolant is able to make it to and from the overflow reservoir from the radiator is actually really, really smart in my opinion. If we take a quick look at the radiator cap again, we can see that the black part, the rubber part, is spring loaded. So you can see I'll push in with it with my thumb right here. Now if we look back at the car and see how that overflow reservoir was connected to the radiator, we can see that where that hose leads to, that hose kind of connects right here, and there's this ledge or lip between the coolant and the radiator and where that hose goes. So you can see, I will show you with my finger, that's where that hose is open. So the way this works is when the pressure in the radiator gets so high, it compresses that spring on the radiator cap. That rubber part moves up and it allows pressure to be relieved into the overflow reservoir. The vice versa happens when the cooling system cools down. When pressure in the radiator drops, it creates a vacuum that sucks coolant in from the overflow. I'd like to better demonstrate to you guys how the coolant flows from the overflow to the radiator. We'll start off by removing the overflow by shaking side to side and sliding up. Now since I've got my overflow reservoir in the air and the radiator caps removed, you can see that gravity allows coolant to flow from the overflow into the radiator, as shown here. If the radiator cap was installed and the system was not pressurized, this movement of coolant would not be allowed. Now that we're done discussing how the cooling system works, let's get started. So I've already removed this underbody plastic aerodynamic piece to allow us access to the radiator drain. I'd like to mention that in the video you can see the car is jacked up, but you don't actually need to raise the car to do this. You could theoretically do it without jacking the car up. For those of you curious why there's two sudden speed ups in the drain rate of coolants in this video, the first one occurred when the overflow tank ran out of coolant and air was able to get into the radiator faster. The second one occurs in a few seconds. It's when I realize the overflow is empty and open up the radiator cap to make it drain faster. Now before we forget, we will reinstall our drain plug. Technically you didn't even have to fully remove it from the start. The O-ring can be reused. Do not over tighten it. Do not use any tools. Do not break the plastic radiator. Since I drained the radiator with the radiator cap on, as you can see here, all the fluid that was in the overflow reservoir was siphoned out into the radiator and then onto the ground really. I'm now going to demonstrate how to remove the cylinder block drain plug to get the rest of the coolant out of the engine. Although this is recommended in the factory service manual, after doing it and seeing how much coolant comes out, which you will later see in this video, I don't personally recommend any of you going through all of this trouble for practically no benefit. I'm still including this as part of the video, as I understand some people may want to do this. Also, some people flush their cooling system with water, and since Mitsubishi coolant comes as premix, if you flush your cooling system with water or some other flushing solution, you will have to try and remove all of that if possible. Here are a couple of photos of the drain plug we will be struggling to remove together. Note that this photo is taken from the back of the engine. The thing at the very bottom of the photo, the black thing, is of course the oil pan, and on it, in the very bottom right corner of the photo, you can see the oil pan drain plug. The drain plug we're interested in is in the middle of this photo. If you're wondering why there's those green and pink dots on it, that's like a paint marker they use at the factory. It's kind of a tamper seal. The funny part about this kind of tamper seal is that even Mitsubishi doesn't know whether or not you should be tampering with this drain plug. They just tell you whatever fits their narrative at the time. If your engine blows up after 8 years and you try making a warranty claim and Mitsubishi sees that you haven't tampered with this plug, they will deny your warranty claim as you have been negligent with maintenance according to them. And if your warranty claim is related to the cooling system and you have tampered with this plug, they will look in their computer system to see if you've purchased OEM coolant and have associated that purchase with the VIN. Because whenever you make a purchase in North America at a Mitsubishi dealership, you must provide a VIN number. They will see you did not buy OEM coolant with this VIN number. They will deny your warranty and blame the coolants. Alright, now that my rant's over, I've already broken this drain plug loose with a 6mm Allen key. You can watch me remove this drain plug and you can judge for yourself how much coolant comes out. Alright, now that we've got our drain plug out, we can install our new crush washer. Something I realized just now is that the crush washer is not on the drain plug. It's somewhere else. I didn't realize this at first, but looking back at the engine block, the drain plug was stuck flush with the engine. Here's me with a pocket knife. I'm going to try and pop it out without scratching the surface up too much and causing a leak or ruining the threads. You can't really see it here, but right when I pop it out, it hits me in my left eye. Thankfully, I was wearing eye protection. Now we can go ahead and reinstall our drain plug with our new crush washer. In the video, I am actually doing this from on top of the car. I am standing up straight, leaning over the car, and my left arm is reaching around the left side of the engine. I can't see what I'm doing at all. This drain plug gets tightened to 18 foot-pounds. When you do this, don't be dumb like me. The 6mm Allen key I bought only came with a 1/4 inch hex, and my 1/4 inch torque wrench can't hit 18 foot-pounds of torque, so I had a 1/4 inch to 3/4 inch adapter, then a 3/4 inch to 1/2 inch adapter, and all that was kind of difficult to work with. In the video you can't really see it, but I've got a 2-inch extension on the torque wrench. I recommend you also prepare yourself with a couple of very short length extensions, kind of see which one works best for you, as the torque wrench can't sit flush with the engine when you tighten this. To give you guys an idea of where to shove your arm to blindly access this drain plug, if we look at the left of the engine, you can reach around with your left arm below this exhaust manifold, below the exhaust heat shield. You can see that rusty ass drain plug. That's the thing we're trying to undo and redo. Now that we're done draining the old coolants out, we can start adding in our new coolants. I use a funnel here, but you don't really need to. I don't recommend, and you don't need a spill-proof funnel or any fancy equipment to do this. Just keep adding coolant until it overflows. There's also no benefit in filling up the overflow reservoir right now. Now that we've got the radiator full, we've started up the engine, and we are just going to keep adding coolant as the engine water pump circulates the coolant around and gets all the air out of the system for us. After a few minutes, you'll notice that the coolant level no longer goes down and the radiator is no longer accepting coolant. It will look full like this. You can squeeze the top radiator hose and coolant will come out. No bubbles will come out. You can go ahead and close up the radiator cap, fill up the overflow reservoir to the full line, and we are done for today. Here's the official factory service manual instructions on how to do this coolant change. If you're curious, the amount of coolant needed in the automatic transmission is more than the manual transmission is because the automatic transmission has a transmission cooler bolted to it, which is a coolant, the transmission fluid heat exchanger.